Hello, in this video we're going to take a look at the cheap-ass transmitter, and as I mentioned a few videos ago, I started off making one like this basically completely from scratch, and I had some problems with the potentiometers, and along the way I found this one here, which is actually extremely cheap and comes with a lot of the stuff that we need already. So I'm going to wire up my Arduino inside here eventually, but the nice thing about this one is that it also gives us the opportunity to use it as it comes with the ordinary receiver as well. So basically what I'm saying is that this whole video that I'm about to continue with here is about this one, and it's probably no longer relevant. But since I recorded it and did all the editing and everything, I think I'll upload it anyway, and hopefully it will be useful for people that do actually want to make something like this themselves. Just before I continue with the rest of the footage that I recorded earlier, I just thought I'd mention, because I spend a lot of time in the rest of this video complaining about how terrible these joysticks are, and I think I just got a bit unlucky actually, because the ones that I had were, I think they may have been made for Xbox or a slightly older generation of Xbox, but as far as I can tell, if you get joysticks that are made for PlayStation 3 or 4, PlayStation 4 at least I think should be okay. That's what these ones are. They have no dead zone, so I'll put a link in the description to where I eventually found some potentiometers or some joysticks with nice potentiometers that did work, and I finally did manage to overcome the problems that I do a lot of griping about in the rest of this video. Hey, how's it going? In this video I'm going to build my cheap-ass transmitter from this bunch of bits and pieces here. Now, radio-controlled transmitters for helicopters might look fairly complicated, and some of them are, but the basic way that it works is you have 4 potentiometers for one for each axis of control. So a potentiometer is just one of these things really. This is a dial one, and all it does is it has a negative and a positive side there, and then this S, which is the signal, tells us at what point between the negative and positive the dial is at. So if I set the dial right to the left position, the S pin would have 0, or it would be the same voltage as at the negative. If I put it right to the other side, we'd get the same voltage as at the positive pin. And if I put it in the middle, well, it'd be somewhere in the middle. So that's what's going on inside a transmitter. There's 4 of those. So we can take that input and read it into an Arduino as an analog read, and then we can use the NRF24 radio module to send that. So before I get started here, I'll give you an overview of all the circuitry that I'm going to put together so that you can see how everything works, because once again, the way I'm putting everything together here is not really any sort of a special way that you need to do things. So you can come up with your own design, get something that you like, something that's easy to hold, something that maybe looks a bit better than what I'm going to make. So yeah, I'll just explain all the circuitry first. Obviously the first thing we need is a battery, and depending on whether you're using 4 or 6 AA batteries, you'll be getting around about 6 to 9 volts coming from that, and we want to use that to power an Arduino. You can use any type of Arduino. I'm using a Pro Mini because they're nice and small, and I kind of like them. And so we can give that a ground input there and another one there. Pretty easy, either is okay. Now for the positive input, you may notice a VCC here, but this VCC is only to be used as an input voltage if you already have the correct voltage that the board requires. So this chip in here, for example, if this is running at 3.3 volts, as is the case for a 3.3 volt Arduino, you should only apply 3.3 volts to here. So if you want to use voltages higher than that, like we have, what you need to do is apply the input voltage here on this raw pin at the top, and that will mean that the Arduino will take that voltage and it will regulate it internally to the voltage that it needs. So just to check what the maximum voltage we can put on here is, just in case you have any other different kinds of batteries that you want to use. Let's check on the website for the Pro Mini, and around about here we can see that both the 3.3 volt model and the 12 volt model, and the 5 volt model can take a maximum of 12 volts there. So that 12 volts is referring to what can be given to the raw pin, not the VCC pin. Okay, so just make sure you do not put this full 6 to 9 volts onto the VCC. Don't do that. I've done it. It doesn't work. Okay, so that'll give us something like that. Then we have our two joysticks with the 4 potentiometers on them, and they each need to be given a positive and negative voltage, and this isn't really to give them any power to run them or anything. They just need to be given 2 reference points so that when the potentiometer wiper slides between them, we can get a reading of how far it is along between them. And each one of those 2 signal pins on there will need to be brought to an analog pin on the Arduino. So obviously the most convenient ones to use are analog pins 0 through to 3, because they're right on the edge. There are some more inside here, but they're kind of awkward to get to, so I don't usually bother with those. And that's about it for the input side. And as you can see, it's getting a bit cluttered already, so there's quite a lot of connections, but nothing is really complicated. I'm going to actually clear that away now for the next part, because it's already getting to be quite a full screen. Okay, so for the output side, obviously we will have a radio module, and the radio module needs to be powered. Now again, we need to be careful with how we power this, because this particular module is only able to accept up to, I think, 3.6 volts as the absolute maximum. So for the ground, of course, we can put ground on here. That's easy. Now this 3.3 volts, where can we get that from? Well, you may have remembered from a moment ago I said that we have 3.3 volts coming out there if we're using a 3.3 volt Arduino. If you're using a 5 volt Arduino, this is going to be 5 volts here, so that's already out of the question. So for that reason, I would recommend using a 3.3 volt Arduino, because you can potentially do this and connect up your radio module to be powered from the VCC of the Arduino. And I've actually been doing that for quite a while, and I haven't had any problems with it. But what we're using here is the high-powered version of the radio module, and I have read that it's not a good idea to power this high-power version of the module from the onboard regulator in the Arduino. So I don't think I will recommend to do that. And if you're using a 5 volt Arduino, you can't do that anyway. So what I'm going to do for this build is I have a separate power regulator. It's a tiny little thing about the size of a fingernail, a lot smaller than it looks in this screenshot thing here, but that can be used to power the radio module like that. And of course it will also need to have its own ground and positive input. So it's going to take this 9 volts coming in here and convert it to 3.3 volts for us. Okay, that's almost everything. It would be nice if that was everything, but unfortunately we also need to connect 5 of these pins here from the radio module to the Arduino, so that the communication between them can be done over SPI. So unfortunately that adds another 5 connections that are necessary. So that's why I said it was getting pretty cluttered. Now these connections here, like I said before, nothing is too complicated here, but there are a lot of connections. So one page I use to check these every time, I always go back to this page. If you do a search, Google search for NRF24L01, right near the top you'll see this how-to page there, and if you go to that page you'll see quite a nice pinout listing for the radio module, and just below that there's a graph here, a chart rather, table rather, and in this column here, Arduino pin for RF24 library. This is the pin numbering that I've used, so if you want to use the Arduino sketches that I've used without having to change anything, you could just use the same pins here on the Arduino as are in this table. So that means that the radio module pin 3 will go to Arduino pin 9. And in this diagram here I've used the same colors there, so just so you can double check which wires are which. Well, hopefully that makes sense. And there's a couple of bits that I didn't mention that I have here, and that's just a switch to turn the power off and on, and also the antenna which goes into the radio module like that. So everything else I think I mentioned there. Now I want to talk a little bit more about the joysticks or the potentiometers that I'm going to be using, but first I'll give you a little look at some alternatives, because these, while they should be usable, I'm not really expecting them to be so comfortable, shall we say, to use. So what I have here, I bought these online for a couple of dollars or something, but as far as I can tell, they are exactly the same as what you find inside an Xbox or a PlayStation sort of controller in the analog sticks. So if you have one of these lying around that you don't mind breaking, you could probably hack into it and join your wires onto the back of the potentiometers that are inside there. So that's one option. That would give you a controller unit that you can already hold, and you may even be able to use some of these switches for something later on. So that's one option. Another option, if like me, you happen to have bought another tiny little micro helicopter for practicing your flying skills, you'll find that the cheap transmitter that came with it actually has the same kind of potentiometers inside here already, and I managed to successfully use these. Once again, they're not very good, like they don't feel very good to use when you're flying because they're a bit stiff and they're just a bit crappy, but you can use them just fine. And if you look on the side here, you can see the potentiometers, the two green bits there. So that's just like the potentiometer that I was using to explain things before. It's just the same thing, but a much smaller version. So if you look underneath the circuit board for those, you should see something a little bit like that. So there'll be the 3 pins coming out the other side, and the one on each side will be the positive and negative connection, and the one in the middle will be your signal connection. So you can see when the potentiometer turns like that, it's going to give you different readings into your analog read into the Arduino. Right, now probably the best solution, and one that I've gone for my not quite so cheap ass project, is I bought an old transmitter off an online auction that was broken, so it didn't work as a transmitter, but the potentiometers behind the sticks here still work just fine. It's pretty hard to break them, really. I don't imagine you could find an old transmitter on a second-hand auction or something that had the potentiometers broken. So anyway, I've repurposed this one for my Arduino projects so far. So if you can find something like this, you can probably get it fairly cheap. And another thing I should also mention is that ideally you want to have one axis that doesn't return to normal, so return to the middle. So you can see here, when I let that go, it's going to return to the middle from any position. This one over here, if I let it go from here, it only returns to the middle in the left and right direction. And for the vertical direction, I can just push it up and it'll stay there wherever I left it. So this is how radio control helicopter and airplane controls are supposed to work, because this is the throttle. So you just want to leave that, have it so that it doesn't go changing itself unless you change it. So if you use one of these, you'll find that this potentiometer is already like that. So it'll stay wherever I put it. Now unfortunately, these Xbox type ones, if you got one of these, you'll find that they always go back to the middle all the time. So what we have to do is take the spring out of here, and unfortunately we can't take the spring out of just one axis only. We have to take the spring out completely. So what we'll be left with is, I have one over here that I've tried this with already. We'll be left with a joystick that just goes wherever you put it all the time. So it doesn't spring back to the center in any axis at all, which is not really ideal, but it's better than having it spring back to the axis all the time from everywhere. So hopefully that's clear what I'm trying to get at there. So it just goes anywhere and stays there. But that's better than springing back. So this is pretty tricky to do, but hopefully not prohibitively tricky. So what this one here is actually, I think it's the same, exactly the same as what's on this, mounted on this board here, except the board makes it a little bit easier to access these pins. So this one was a lot cheaper too, by the way. So you might find it a little bit easier to take this apart if you get this version, but then you'll have to mount it onto your, like, whatever kind of base plate you have for your transmitter. So that'll be a little bit tricky, whereas this one's easy to mount. But the problem with this one is, to open it up and take the spring out, we're going to have to take all that solder off these main 4 points, and also of the solder will have to come off from these 4 points for the switch, because there's actually a push button switch in there. And that's probably going to be quite tricky. I haven't actually tried it yet, so I'll give that a try now and see how it works. The first part of it I know is fairly simple, and that is to pop the side potentiometers off. So the potentiometers are just sitting on there like that, and you can see that they, oops, oh, I gave it away. You can see that they rotate around like that, right? So to get those off, hold on. To get those off, you can just push in from the side, and there's a little tab that should come undone, like that. Now, it's easy for me to do this one because it's not soldered into the board, whereas this one is going to be soldered into the board, so it'll be a bit tricky. So I'm thinking maybe I could just bend that outwards. Anyway, once we've got those off, you then need to, where are we? You then need to lift up these little tabs there so that you can pull the plastic piece upwards. So there'll be 4 small metal tabs that you can try and push back. This is pretty tricky, I admit. This is probably one of the trickiest parts of this whole project. But when you get rid of those tabs, or just push them out of the way, you'll find that you can lift the plastic base up and out and off, and you'll see in there, under that you'll see that now that the spring is not active, we can just sort of wobble it around anywhere, and you'll see that this piece that was pushing against the base can just be taken out, and then also the spring can be taken out. So that's the pieces that we wanted to get rid of. Once you've done that, it'll be very, very floppy and it'll just flop around everywhere. But you should find that once you put it back together and you get the potentiometers stuck on the sides again like this, then those potentiometers should have enough friction so that it just stays where you put it. So I'm going to give this one a try now, doing all the desoldering and stuff, and I'll let you know how that goes. Okay, well, I managed to get it done, but it wasn't very easy. It took about an hour actually, and I managed to stab myself in the thumb as well. But now that it's done, it's actually very smooth, a lot better, smoother feeling than I thought it would be. And it sticks in any position you put it. There's no notching or scratching. So the result is actually fairly good. So I'm glad I did that. Okay, I've put everything together. It's starting to look a bit more like a transmitter now. I used the little plastic covers that come with these sticks because they were not actually too bad. I didn't want to use them, but when I put them on there, they kind of feel okay. So we have ground and positive connections here, and then the two yellow and the two green wires are the signal, and they go through the back here. And I have not connected everything up just yet because when I do that it becomes very cluttered, and I just wanted to give you a little look at it before I connect everything up. So I have my batteries down there just with the power switch there, and I'm using some pin headers soldered together on the rear side like that to use as my positive and negative rails, just because that's a handy way to connect a lot of things all together without having to use any prototype board or anything. So I'm just going to sellotape them down like this. And then up here we have our step-down converter, the radio module, and the Arduino. So I have just the analog ins from the potentiometers hooked up here at the moment, and this is the 3.3 volt VCC, so that's going to go to this positive rail. So this positive rail is my 3.3 volt positive rail. It's not the one that comes from the battery. So the battery is going to go into the DC converter there like that. So let me just hook up. I just want to do a little quick test to make sure that I'm reading the values from the potentiometers correctly before I go any